Join us for 3 days in Orlando, Florida in February 2025 for an event designed to equip IT professionals like you with the tools, knowledge, and strategies to navigate the ever-changing cybersecurity landscape. Secure your spot and register to join us for 3 days of immersive learning, collaboration, and skill building with hands-on hacking labs and much more.
It's good to be reminded of all of the threats that we face and the different ways that we're vulnerable.
You're only as strong as your weakest link, right? You can have all the tools that you want in place, but if you're not taking care of the end user, I think that's the weakest link there.
Network with peers from around the globe, share experiences, and learn from real-world case studies, all aimed at enhancing your capabilities as an IT professional. Register now for Zero Trust World 2025 and take the first step towards a more secure tomorrow.
Morning, everybody, or good afternoon, depending on which part of the world you're connecting in from. We've got a bigger team here today. We got Nick and Kieran both joining us to help us with one of the most complex topics to unpack. And of course, Rob's here as well. We're going to try and do something slightly different today. We're going to try and keep it a little bit shorter because it seems as though we get too many questions. So please feel free to post your questions in the Q&A. Please don't be offended if Rob doesn't answer them. Rob has OCD when it comes to answering questions, and it can make these webinars go on a very long time. So we're going to answer some of the questions.
It's completely my fault then, Danny, that these go on for ages.
It's always your fault, Rob. Unless it works. So, we also have some extra thing here that some reason the building air conditioning is not functioning properly. So if I start wiping my forehead or Rob turns red, then that's why. So it's
no, your Rob turns red on a day that ends with Y.
Okay, so that's true. Okay, so we want to talk about supply chain and the risks about supply chain. And one of the things about supply chain attacks is we can have this great security in place, and then we go and buy somebody's software and it breaks our system. It becomes an entry point for attackers. And there's really three types of supply chain attacks. And the one that I think everyone's most scared of, I'm not sure if correctly, is the backdoor, the intentional backdoor where you buy software from somebody or you install software on your computer and somebody puts something in there, the vendor puts something in there so they could gain access to your computers. And we've seen this, or it's been reported on at least that this happened, of course, with Kaspersky. Kaspersky is a good example of Lenovo it happened with, although that was claimed to be unintentional, where malware was shipped out with computers. The backdoor is the one that people fear the most. Now, the reality is that's not too often, but it obviously does happen. SolarWinds is a good example of that, where it wasn't an intentional backdoor, but it was an unintentional backdoor. And now this one's a little bit scarier because in that case, the companies that use SolarWinds Orion vetted the company, they looked at their SOC report, they checked, did they trust them? And then they bought the software, installed it on the most critical systems, only to find out there was malicious code embedded in the backdoor. And this is really the second type of supply chain attack. And this is, again, really, really bad when it happens, not too likely to happen. There's a couple of examples that it has happened, but doesn't happen too often. Now, with SolarWinds, I think what happened in that case was somebody actually gained access to SolarWinds source code. And when they first did this, they wanted to test, can they put malicious code in without getting detected? So they first put some benign code into the source code. Now, this should be picked up. So as a software company, we have something called code reviews. And when you write code, somebody else has to review that code and walk through everything you've done. So they put some benign code in there that didn't do too much in 2019 and allowed it to go through a code review, checked it got deployed, nothing happened, wasn't detected. So then they went back in and they actually wrote more malicious code. And the malicious code essentially reached out to the attacker's server, which was, I believe, hosted in AWS, so US IP address.
New Jersey.
New Jersey. Okay, well, maybe suspicious. Hosted in New Jersey, and the server then reached out to that server in AWS to get instruction, and it waited 3 weeks. And the reason it waited 3 weeks is because it wanted to get through SolarWinds' QA process, make sure it didn't do anything bad. Should have got picked up a code review, but obviously didn't. Now, this one's particularly bad. Obviously, the US government is bringing charges, or at least trying to bring charges against the CISO at SolarWinds relating to this. And the reason this is because the US government's terrified because they don't know what they got access to. In this case, it was running on their machines for months. They weren't aware of this backdoor happening. Somebody essentially could have sent instructions to their servers to do pretty much anything you wanted, call out to PowerShell, upload files, extract data, and then send them off to someone in Russia. And that's obviously terrifying for the US government. So this one was particularly bad. And companies that were using SolarWinds don't necessarily know how bad the damage was. Now, the third type of supply chain risk is the most common, which is the vulnerability. And this is where an attacker just misuses an unintended feature or a vulnerability in the software to gain access. And that could be that Log4j is a perfect example. There were Log4j, a component that is used by thousands and thousands of products, if not hundreds of thousands of products. It essentially allows you to log very, very easily into a log file without having to write much code. And what it did is it had lots and lots of code in it. And some of that code essentially allowed attackers to execute payloads through the logging mechanism. So for example, let's say you had it on your firewall. They may be able to connect to the web interface on your firewall, try and log in with a bad username password, which would trigger a log entry, and then inject something into that log entry, which would cause remote code to be ran. You could create user accounts. You could potentially gain access to a system. Now, Log4j is just one example of vulnerabilities being used. If we go through the history, I mean, 2021, there was a vulnerability in Kaseya that allowed attackers to push out ransomware using a tool that was designed to push out software updates and patches, and essentially a security tool. Because the software had the ability to push out software, they could inject and insert. It was a SQL injection attack. They could insert essentially into the, hey, push out this package, ransomware being the package. Office had a vulnerability in 2022, I want to say, that allowed you to embed a payload in a Word document. And when the user opened the Word document without enabling macros or doing anything, it could cause Office to crash or Word to crash, and then call out to PowerShell and run some malicious code there. So these are just a few examples, but vulnerabilities, there's over 21,000 CVEs on average created every year. So we're talking about a couple of them, and most of them aren't particularly too serious. But when they do happen, people often don't realize they're running unpatched. And on that, I want to actually bring in Nick to talk about the Minecraft server vulnerability, because we're all using Minecraft in our offices. Apparently, Nick managed to install it today. Everyone raise their hand if they've got a kid at home that might have a Minecraft server. I don't know if they, well, they definitely don't, because my kids run ThreatLocker and they can't do anything without, unless they social engineer their mother into allowing them to do it. So Minecraft servers, can you explain what a Minecraft server is? I don't play computer games, by the way. I refuse to waste my life on a computer game. But Nick, do you want to explain what a Minecraft server is?
So Minecraft server is just a regular application that you run on some other machine, and that machine hosts the entire game for everyone to play on the same world and stuff.
And let's talk about your environment here. So you have a machine, obviously it's a VM, and you've installed a Minecraft server.
So I got my server on my virtual machine right here, so we can actually see how it works. So we have ThreatLocker and everything. In monitor mode, so we can actually see an actual exploit happen. But it's just a regular application that takes in data and waits for someone to connect in. So I already connected in. So with this exploit, Minecraft for the most part is already patched because the vulnerability was out like about a year ago. And that being said, you may think that you might be safe. However, if you have a kid that likes to play with mods, a lot of mods are out of date, so they'll be playing with out-of-date versions of Minecraft. Like this one here.
Let's break it down, because for the people like me who don't understand computer games, so you can patch your Minecraft server, but then you have a mod which might not be patched. Is that accurate?
No. So it's that I'm just playing an older version of the game because I might have mods that aren't updated to the latest version of Minecraft. Some people will choose to use a earlier version, either for nostalgia or because they actually have some cool, fun things, like what I have here. A computer is normally not available in normal version of Minecraft. The problem with this exploit is that anyone who connects to the server can run it. A lot of things in Minecraft are logged, including the chat. Now, the problem with doing that is that I could do something like send a message like this into the chat. And when this goes into the log, it will tell the server to try and be able to get information from somewhere else. Technically, this tries to get information back to my machine and tries to pull down other Java code to run instead.
So you've created a Minecraft server. So you've got 15-year-old son, built his own Minecraft server, probably doesn't give two shits about patching his server and keeping up to date. You now, as the attacker, you've connected to this server, which is open on the internet, and you connect to and you send a chat message, which allows it to, which tells the server to download JavaScript from another machine and then run it on the server.
So this log4j is based on like whatever is logged onto the server, and every single message that is sent in the server is logged for all sorts of reasons. Because of that, I can just post this into the chat, this exact string, and just send it out. And then what the server will do is it will try to get some Java code from this server that I sent it to, which is me. It's something I control. And it'll run whatever code that I have set up on there for it to grab. So once I send this, it will, as you can see, this has gone off and it will give it an exploit class file for it to run. And over here, we could see it gave me a shell. I can do all sorts of things here. I have it's not a full administrator shell, but it can be if the person running the server is running it as an administrator. So it's always important to be careful about like who you run your server as. Just by being able to log in to play on a server, I have been given full control of the full computer itself. We can find some ways to be able to avoid that. Biggest worry though, even though giving full access to the computer is already a problem, this allows an attacker to see all the information on the server, including the logs themselves.
So when your kid asks you to open up your Bright House or Spectrum firewall or your Comcast firewall to allow a port from Minecraft, say no. Because of course you've got onto that machine, you've got full reverse shell. You could have scanned the network. You could have done anything on the LAN in the house. Now, I tried to do something in my house recently, which was to separate every device so it couldn't see each other, because I used network control on my laptop, so nothing can scan it, and I've got all ports closed internally. But I tried to be a bit smarter and say I don't want anything to see each other. And then everything broke in the house because I couldn't control the Apple TV and I couldn't screen share or and do things like that. So it got a lot more complicated.
This kind of vulnerability affects even though it affects the server, it's more dangerous to the clients themselves, because if we look up in the server logs, which are saved on the server itself, we should see somewhere where I logged in. Oh yeah, player, that's me, Radiologic. I logged in at this IP address and logged in with this port. So since these are logs stored on the physical system, I'm able to see the IP address of everyone who logs into play on the server.
If they're hosting the server, they'll be able to see where they live anyway. Question, what happened? So you've got ThreatLocker on this machine. You've put it in monitor only. Do you want to show us those logs and walk through what actually happened in the background?
So luckily, with ThreatLocker, we can actually avoid a lot of this. If we actually use a ring fencing policy, the reason why this is able to trigger is because the login server is being told to find information from somewhere else on an LDAP server. For most applications, Minecraft included, but can include a lot of other Java applications that use Log4j, most of the time, they don't need to have access to this LDAP server. So we can create a ring fence policy that's meant to block it from ever running. So if I go over to here, you can see I have a little ring fence on the Java application itself, and I tell it to, if I go to network part, I tell it to deny any access to this port. So everything else will run properly, but any connections to that port will be blocked and killed off. So I can enable it here, and I can take my computer out of monitor mode into secure mode so you can actually see it in action. Because everything else here is going to be allowed, since it, for the most part, should be permitted for any Java application. But now that that ring fence policy has been set, we can go back here, wait a couple of seconds, and the next time I try to connect and run this, we should get stopped. So I'm just going to copy this again, and I'm going to set up my listener just in case it'll give me another shell. Because, hey, I'm an attacker. I always want to get a free shell in a server. So if I go ahead and run this, you can see I typed it in, and nothing's happened. It's just a nice little bit of text, but if you look over at the server, we can see that it got several errors here, mostly because the socket was denied permission to connect. So even though the exploit did successfully run, it was not able to connect to a malicious server to grab whatever code I want and tell it to execute it. So even though this server is unpatched and technically still vulnerable, I cannot utilize it because of the fact that it can't even reach out. So the easiest way to keep things secure is to limit what things an application can do and only allow it to do what it's supposed to.
But the reality is, it doesn't need to. The Minecraft server, obviously, it needs to accept inbound connections, and it needs to reach out to certain IP addresses on the internet, like Microsoft's IP addresses, but it doesn't need to reach out to that random Java server.
It doesn't have to reach out to that Java server, but it has to be some Java server on that port for it to be able to work.
Okay. So in the bottom, the main point here is if you what you should do is go in and ring fence both your Minecraft and your Java to only see what it needs to see in its environment, because we wouldn't have seen it go out to that malicious host to download. And also it won't be able to call things like PowerShell or command prompt. So if we'd set it so we couldn't launch command prompt from Java, which we don't need to in most cases, then the attack gets stopped. Now, there's another thing you could do also, which is make sure the server's patched. But the reason we ring fence is for the unknown vulnerabilities and not the known vulnerabilities. Now, I think there's a couple of questions.
Which is just don't allow Minecraft on business machines.
Well, that's a better solution, or any machines.
Well, that's true as well. Am I allowed to ask any questions?
There's a few questions you can ask some questions of.
Okay, Christian's asked a good question. He's a bit worried. He says, so if I have an Xbox that's connected to a Minecraft server, my entire home network is at risk. No.
So in this case, no. Well, let's rephrase that. So the answer is never no, because we don't want vulnerabilities. But this vulnerability would not make your home network at risk because you are connecting to the Minecraft server. But if you had a Minecraft server, it would be.
Richard has asked about Ternos servers. I'm going to ask Nick what that is. Nick, do you know what a Ternos server is? Hosted Minecraft? Safe?
I don't know for that one exactly, but if it's a hosted Minecraft server, you should be safe from this exploit itself. The hosted Minecraft servers would have been patched by now for this. It's more for the home user that this would be targeting today.
Right. Yeah, because these patches came out pretty much days after the Log4j issue happened, and there are ways to patch pretty much every version available now. The latest versions are already patched by default, and even the Forge server that I made for this demonstration has a patch available. I just need to run it with the configured options.
I think probably the point that people need to understand is this isn't about Minecraft specifically. We're using it and they're doing it in the context of a Minecraft server. But realistically, what we're using here is a Log4j vulnerability. It was in thousands of pieces of software, everything from, UPC backup software or APC backup software to Minecraft. And the difficulty with it was that it was all provided by different vendors. So you had to wait for those individual different vendors to provide patches that fixed the Log4j issue in their software. And it affected, they reckon, 3 billion devices. 3 billion devices were running software that used the problem version of Log4j.
And I think I haven't done an audit in a couple of months now, but I don't think I've seen an audit in ThreatLocker where we haven't found some software running a vulnerable version of Log4j still today. Now, that doesn't mean it's exploitable, because in order for something to be exploited, you must be able to connect to it and do something with it. So if you've got a local app that has no open ports and doesn't ingest data, then it's probably not exploitable. But you should still get it patched, because what you don't know is what will hurt you. Now, Log4j, or actually SolarWinds is an interesting one as well, actually, because one of the things you can do to stop a lot of attacks, it's actually really simple. Now, we have something ThreatLocker called ring fencing. What that allows you to do is actually go into any app and say, what does this have access to? Does it allow access to the internet? Which servers on the internet? So in the case of SolarWinds Orion, clients who had SolarWinds Orion log ring fence, so it couldn't see anything on the internet except SolarWinds, that exploit was foiled because they couldn't get the instruction. Now, you don't have to use ThreatLocker for that. You can also block outbound internet access on your servers. It's a cheap thing to do. It costs nothing. You shouldn't be browsing the web from your servers anyway. And if you just set your firewall to this device cannot go on the internet, the probability of a vulnerability being exploited goes down massively. So really sensible things. Other things you can do in ring fencing is you can say, this program doesn't have access to these files. We're going to accept that some way it's going to be exploited. Make sure it can't see more than it needs to when it's running. It can't talk to PowerShell command prompt or any other applications on my machine except the ones it needs to talk to. If you limit an application's access, you can really harden the environment. SolarWinds, Log4j, similar scenario. There's so many programs you're going to have that are running vulnerable versions, just limit what those programs can do. So if they're exploited, they can't step out their lane. Now, you had some stuff on the EZ or EZ, depends on which side of the pond you're from. And Kieran's kind of from all over the world, I think. EZ utilities. Do you want to talk about that, Kieran, a bit?
Yeah, it was the XZ utils. It's a widely used open source software for lossless compression, and it's used in most major Linux distributions. And the problem with this is it's open source, but so everyone really used it. It had been around for years. But starting in late 2021, someone by the name of Tan started pushing code to the XZ utils GitHub. And then after a while in early 2022, people that are now believed to be linked with that person started to publicly complain that his contributions were not being merged in a timely manner, because the original creator of that utility, he wasn't really pushing updates very often, every few months at best. So then eventually, Tan was added as a maintainer so that he could just push the updates himself so that it wouldn't have to wait for the permission. Then all throughout 2023, Tan, pushed updates as usual, made everything look fine. No one really thought there were any issues. But then in February of 2024, he merged a hidden backdoor into the repository, and it was actually included in multiple beta releases of Linux. So that was in Red Hat and Debian. Both of their beta releases had the vulnerability. It was only caught when Andre Freund, he was a principal engineer at Microsoft. He was doing some testing at home, and he realized that his SSH login, he expected it to take about 0.3 seconds, and it took 0.8 seconds. And then after doing some digging, he found out it was because of the backdoor. And that's really the only reason that people found out so quickly, is just some guy doing some testing at home and found the vulnerability. It was a backdoor vulnerability, so it was maliciously placed. If he hadn't caught it, that very well could have gone out to millions of Linux machines, because it was used in almost all of the major ones.
I'm sure Microsoft engineers had no problem telling the world they found their line.
I was going to say, that guy sounds like a nightmare. My SSH connection is 0.8 of a second and not 0.3 of a second. I must investigate.
That sounds like me.
It does sound like, actually, that does sound like you.
So now, Nick, you had some stuff on the Disney breach as well, and obviously we're basing this on reported information as opposed to Disney's own accounts of it. But what happened with the Disney breach?
A few ideas we have is that they were caught in a supply chain attack from the activists that were putting out code. So they put out 2 infected bits of software. One was an add-on for Comfy UI, a graphical application used for creating neural networks and ChatGPT AIs. So the extension they made was for using OpenAI in this application. And even though the extension itself was not very harmful, the dependencies they brought in were dependencies that the attackers themselves made, that made it so that anyone used that library specifically, even if it wasn't for the extension that they made, it would run their code and it would do things like steal the OpenAI API key that you own, and it would add a backdoor onto your machine physically.
I want to, of course, look, there's things you can do to reduce your chance of a supply chain attack. The first thing is review the company you're getting software from. Ask for the SOC 2 Type 2 report. Check that they're a company that has good morals. Ask what kind of QA processes they have. Do they have code reviews? By the way, if you'd done that with SolarWinds, it would have come out smelling of roses. So it doesn't necessarily guarantee, but it doesn't hurt either. Asking those questions does two things. One is if they don't have good processes, you might detect it. The other one is it actually encourages companies to put better processes in place, because there's nothing worse. And I remember we've gone through so many compliance questionnaires now and so many SOC 2, NIST 800, 171 and various different audits. Every time we go through that and a question gets asked, well, do you have this? You start asking the question, no, why do I need that? So it forces companies to be better. So ask companies, ask for their SOC 2 Type 2 reports. SOC 2 Type 2 essentially is an independent audit that you pay them a lot of money for. So, and they come in and review your security controls. Now, it doesn't mean you've got great control. So go into their SOC 2 report. And if they're not doing things like whitelisting, if they're not doing things like an EDR, if they don't have vulnerability patching program in their SOC 2 type report, they're not auditing it. So don't just take the report and say, hey, there's no exceptions, so it's good. Have a look at the controls they have in place and make sure they've got at least the basic controls in place. The next thing you can do is assume it's going to be bad. Assume you're going to get breached. And it doesn't have to be on the cloud. People often ask, is the cloud more secure than on-prem? Well, here's the thing. Let's say take Exchange vulnerability, where there was a vulnerability that you could connect to an Exchange server, and I'll skip the how. We've gone through it in a few presentations, but essentially push out ransomware to an entire organization by creating a GPO, just by connecting to an external port of an internal Exchange server. So in that case, the on-prem software was less secure than the cloud version, because even if Office 365 had the same vulnerability, which it didn't, but let's assume they did, that would have affected your Office 365 tenant and not your internal network. Whereas with the Exchange vulnerability, it allowed attackers to literally create GPOs and gain full control of your internal network. So whether it's cloud or not cloud, make sure you're putting controls around it. If it's on a server, limit its access to the internet, see what it needs to talk to, limit what they can do on your network, make sure it can't run other software. That's how you're going to save yourself from major attacks. You can't control that the data itself may be exploited from Exchange or from the vulnerable software, but you can contain the blast radius. So doing these things are really going to help harden your environment. The other thing is find out what you're running. And I'm going to show you a screen here if anyone hasn't seen this before. We can see everything that's in our environment. And like I said, you don't have to be a customer. If you want to just do a free audit, you can deploy the agent. It will learn. We give you a 30-day audit. We have an engineer who will spend an hour with you going through the results, and we don't charge you anything for that. We'll show you how many computers the software was found on, and what it has access to in your environment. So you can actually go into things like category and say, hey, I want to know everything that is, say, shopping software. So I want to know coupon clippers and things like that. And it will actually help you filter out, oh, I've got a coupon clipper here. We're not here to say it's good or bad, but we can tell you information about the coupon clipper. We can tell you what it is. It's a shopping tool. It's a browser extension. What does it have access to? So our research team will go off and check every browser extension. They'll check what permissions it requests in the browser. So Cooper, for example, requests access to the internet, so it can go out and communicate with the internet in real time. It also detects access to all of your web data. So anything on the form. So if you've got your bank statement open, it could read your bank statement. Not saying it is reading your bank statement, but could read your bank statement. And it also requests access to all of the passwords. So if you log into your bank, if you do anything else, this browser extension can see all of that. And it's a coupon clipper. Is it worth it in a business? So what we'll give you strategy. So obviously this is almost a little bit sarcastic, but it says evaluate the need for this software in your business. There may be considerations where it is required. If it's not required for business use, we recommend you deny it from running in your environment. You can also filter by country. This is one that's getting quite hot. Obviously, the White House issued an executive order blocking the use of Kaspersky in the US, or the sale of Kaspersky in the US. Raised a lot of questions. Well, what other software do I have? Where was it made? You can go into here and you can say, well, I want to know everything that was made in Russia. I want to know everything that was made in China or North Korea. And our research team will actually list every program you've got and where that program has ties to. So, for example, 7-Zip here, Do we believe 7-zip's bad? Not necessarily, but there are things it can be used. So it can be used to encrypt files, for example. A feature, it's not necessarily a vulnerability, it's a feature in the product. It can also be used for data exfiltration. It has had vulnerabilities where you can crack passwords. I still haven't figured out how that works. Maybe that's for Nick's team one day on previous versions. This is what it has access to. In my environment, I've actually changed it. So you could say, well, I really like 7-zip. It's great compression software. I don't want to get rid of it, but my boss doesn't want me to run anything from Russia. And it can also be used to encrypt files. So maybe this is bad. So we can actually go into the policy here and we can start taking permissions away. So we can say, I don't want it to go out to the internet. So if it did have a backdoor in it, it wouldn't be able to reach out to the internet. I don't want it to talk to any of my files apart from the only thing it can, maybe I want it to read my docx files or read everything. I can say it can read every file, but it can only write to .zip files, and I think I need to put a star in there, and 7-zip files. So this is really useful. So look at the applications you have, go through, see what they need access to, and then take away access to everything else. If you're not sure, does this application need access to this? We can very quickly put it in a monitor only mode policy. So what we would do is would set the policy up that we believe is accurate, would set this to monitor only, and then a week later we can do a simulation on that policy and see if anything would have been denied. And if nothing would have been denied, you can implement the policy and go fully live. Otherwise, it will just inherit from your standard status.
Well, WinZip is one example, but WinRAR is another. Is actively used by ransomware operators. It's not a bad application per se, but it can encrypt data, it can delete data, it can exfiltrate data, all characteristics of ransomware, basically. So be very careful about things like things like WinRAR and 7-zip running in your environments. So Mike has asked, is there a list of report types we should confirm vendors have? Your opinions, is there minimum certifications a vendor should have? Assume vendor will be working with production data. Is there one that confirms their code goes through proper reviews or at least is audited by a third party?
Every single compliance certification essentially allows for exceptions. And without actually digging into the reports, it doesn't matter whether it's SOC 2 or, I mean, things like FedRAMP are pretty strict, but it doesn't necessarily guarantee it goes through a review process. But what you can do is look at the report they have. So in the US, SOC 2 Type 2 is very common. In Europe, they tend to use ISO and they'll get certifications on those. Look at the controls they have and ask them the questions. I think it's very reasonable to ask, do you have a separate person doing code reviews of every piece of software you have out there? In our answer, we actually have 2 code reviews. And so that really helps with that, to make sure that one is really quite often finding functional stuff, and the second one, although it does review security, and then the other one is reviewing security explicitly for, hey, have you done something that could allow a SQL injection? But I wouldn't say there's a specific certification, but I would be asking the question. And if they do have a SOC 2 Type 2, ask for some kind of certification and make sure the controls are listed in there for code reviews. But then again, if you looked at the SolarWinds Orion, it was a clean report. There was nothing that would have made you terrified of using it. Put controls in place to limit what they can do once it's running.
That's what I was going to say. I mean, the takeaway from this, and again, I know we went off on a Minecraft tangent, but the takeaway from this is assume software is vulnerable. Assume everything you use has a vulnerability in it. It's just a question of whether that vulnerability is known about and whether that vulnerability is actively being exploited right now. Because it is. I mean, look at an average Patch Tuesday. How many different CVEs do Microsoft fix on average Patch Tuesday? I think there's been either 9 or 10 major exploited vulnerabilities in Chrome this year. As you said, Danny, 21,000 CVEs on average per year. But just assume everything that you use has got vulnerabilities in it and work from that point. So, okay, I've got vulnerable software on my machine. It's going to be exploited. What's the next thing that's going to happen? And typically the next thing that's going to happen is something is going to run. Block everything from running, and that something isn't going to be able to run. Or it could be, PowerShell is going to try and reach out to the internet or run remote code or start up a reverse shell. Again, controlling that, what it can do is going to stop that next stage in that circumstance too. But just assume all your software is full of holes and work from that position, and you're going to be far better off.
There's another one here. Is there a way of stopping extensions from accessing cookies? I think it said. I've lost the questions now. And I think the problem, if you actually look at the permissions, some extensions require permissions in order to function. And to be transparent, like, while Cooper is terrifying to me because we have a piece of software that can see my passwords, it can see my web data. It's not just, I don't believe they're doing it for malicious purposes. I think they need access to your full web data to determine, can they get you a discount on that thing you're about to buy from Amazon? And that's essentially what Cooper does. Then it becomes of, you can't, like, first of all, a browser extension can't necessarily see cookies. So cookies are only accessible by the website you go to. However, if they can read your web data and the web data is submitted, they can't just grab your cookie, but they may be able to scrape the cookie from data being submitted. So if you have an authentication cookie, it might be extracted and then pushed. And it doesn't have to be a malicious browser extension either. It could be a vulnerable browser extension that gets exploited by another site. So it's not always a bad company that's got a bad browser extension. It could be a good company with a bad browser extension. You can also pull cookies from other programs, and we actually have a storage policy in Community, if you use ThreatLocker storage control, that stops other programs accessing your cookies other than your browsers, because quite often you're running executable, it'll scrape your cookies from your browser and then just upload. And the problem is with cookies is if you take, say, the Office 365 authentication cookie, you can copy that to another machine, and now you don't need dual factor, you can just log straight into that account.
Mike has actually asked us a very good question, and I know there is going to be an answer for this, but as a ThreatLocker MSP, how can we make sure that the policies that we implement for our customers are configured correctly? Just to make sure we're not allowing something through inadvertently. Does ThreatLocker have a process to help us review the policies to make sure that we are secure?
So we have a process, and you should be using that process. It's one of the biggest challenges we have is people not necessarily working with the engineers that we provide free of charge to all of our customers. So you have a security engineer, you should go through, and they should be, hey, can I look at these policies? And look, there's no such thing as perfectly secure. But what we want to do every time we get on a call with you is make sure you're more secure than you were beforehand. So what we'll do is we'll look at the applications you're running, we'll look at the highest risk ones, and we'll suggest policies for them. And you can book as many calls as you need with your engineer. Like, normally we recommend a monthly or at least a quarterly call. They'll go through the policies and say, well, how can we harden this? How can we harden this? And there is no end to perfect, but if we can get the biggest vulnerabilities and the biggest weaknesses gone, then we can solve a lot of problems. One example is, the biggest one we're seeing right now is attackers logging into machines and encrypting files from the UNC path, and they're logging into a non-ThreatLocker protected machine. So they'll get another machine on the network, and then they'll just connect to your file server and they'll start encrypting files because they guessed your password and there's no dual factor authentication on UNC. We're seeing that as a big risk right now. So one of the things we recommend is have a network control policy that blocks access to ports if it's not a trusted object. So if someone comes in with an untrusted object, it will not be able to talk to your server. Very simple things you can do. Your engineer can help you with those things. Go through ThreatLocker University, but speak to your engineers. They will help you. And of course, also come to Zero Trust World. We spend 3 days advising you on things you could be doing. And as well, do you want to finish up any final questions, Rob? Or we go on to give it away Zero Trust World?
Says, I switched to CyberHero Managed on MDR. Now I sleep better at night.
MDR is absolutely awesome. If anyone hasn't tried it as well, the MDR, the first week you turn it on, it's kind of a bit of annoying because every weird app you've got is going to flag an alarm, and we're probably going to call you and say, hey, we've seen this. Do we know what this is? It's flagging some suspicious alarm. After that, it's awesome because they are picking up your alerts most of the time in less than 60 seconds, 24 hours a day, 365 days a year. Someone jumps onto an RDP session, you forgot to close a port, you've got invalid logins in your event log, someone tries to run Mimikatz. Even if it's being blocked, of course, it should be blocked first. Someone's on that and they can lock down the machines, they can isolate the machines, or they can call you and say, hey, some bad shit's about to go down on your computers.
And Richard said, I can't emphasize enough to work with your engineer and leverage CyberHero support. Absolutely fantastic resource. Glenn has asked, strange question, any hope for a registry control module in the near future?
You can control registries now with ring fencing.
Ring fencing. Yeah.
So now you have to ring fence each app. But if you go into any app, you check a box and say it can't access the registry, it won't be able to make any changes to your registry at all. And you can ring fence registry editor as well.
Isaiah Jones has asked quite a few questions, but they're probably very quick answers. So what's the smallest and largest type of infrastructure this can support?
hundreds of thousands and millions of endpoints, right down to anyone that's got an IT department to manage it or an MSP to manage it. It's a tool that's managed by someone who's a professional, typically 20 users right up to hundreds of thousands of users. I mean, we've got...
That was one of the questions that I answered quietly earlier, didn't ask you, which is, can we get this for home use? So,
okay, unfortunately...
Sorry, Isaiah, other questions. Does this sit as an agent on each system or remote management software? So yes, it sits as an agent on each machine. If it sits as an agent, does it tax the CPU similar to how Sentinel and Defender have random spikes of CPU usage?
No, so our CPU, because most of our decisions are binary, rather than having to let something run in a sandbox, and where we do run things, they tend to be in the cloud in our testing environment. Our CPU is actually very, very low. Most of the time it's sitting at 0. Now and again, you'll see a little bit of a spike, but it's normally like 10%, it'll spike to or something like that. It's very rarely. We spend a lot of time making sure our CPU performance is incredibly quick.
And the last question Isaiah asked is, does this integrate well with current EDR solutions? What types of studies have been performed? How often this produce false negatives within their environment? I mean, they integrate well with current EDRs. We run alongside all manner of EDRs. I mean, pretty much everything you could mention. The beauty about it is, for the most part, is we do what we do and they do what they do. So we protect, they detect. So they work well together.
We detect as well, but
the other thing to mention, though, is in a lot of cases, when we run alongside other EDRs, the other EDRs basically don't have very much to do, because nothing's been allowed to run they shouldn't be allowed to run. Nothing's been allowed to happen they shouldn't be allowed to happen. So your other EDRs are typically sitting there going, well, it's very
less alerts.
Yes, but they also don't see the things that we block, and that's really important. So things that we stop from running isn't going to be able to misbehave. So we've stopped it before they even see it, before they have a chance to evaluate its behavior. Whereas if you use ThreatLocker's EDR sees everything that's been allowed, everything that's been denied, everything that's been controlled. We've got complete visibility. Where if you run ThreatLocker beside another EDR, that other EDR may not see as much.
Very quickly, it's a cloud-based solution. We do have options for on-prem for very, very large deployments, but they're very, very rare and seldom. So you don't need to spin up your own infrastructure. Guys, if you haven't heard about Zero Trust World, every year we host a conference here in Orlando, and it's a big... It's not a profit conference for us. It costs us millions of dollars to put it on, but I think it's really important because what we're trying to do is help people be more secure, understand security better, and we make it very technical and hands-on. We have some business stuff, some high-end stuff, but a lot of it is, hey, we've got physical labs where you learn how to use rubber duckies, pineapples, Metasploit. We'll show you in more detail. It's a great 3 days. It's here in Orlando, Florida in February. There's a bunch of other things. I apologize if we didn't get through to your questions. There are lots and lots of questions on here. But again, thank you for joining us. Hopefully, if you want to do a trial of ThreatLocker, we're going to throw a link in the chat so you can download a free trial or start a free trial. Someone will walk you through a health report. They'll show you the software they're running, and at very least, you'll know what's in your environment. Doesn't cost anything. If you are an existing partner or customer of ThreatLocker, check out some of the new stuff. The network control policy, most important thing, turn on block SMB traffic, block RDP traffic, unless it's from a trusted object. It's a very easy policy to create, and it does not, it's not going to block anything from trusted devices. So just create those policies and it will really help harden your environment. I can't tell you how many ransomware attacks we've seen where somebody has a device that wasn't protected connecting to their device to encrypt or copy files from it. Really is important. With ThreatLocker Detect, of course, you can set thresholds and alerts on that as well and automatically shut down writes to storage if the number of files changed exceeded a certain amount or read exceeded a certain amount. Rob, Kieran, Nick, thank you very much.
Thank you, Danny. Thank you all.
Yep, glad to be here.